Hello everyone. In this video, I would like to go over this example right here, evaluating the area between 1 and e of this function, and providing the graph of this function is equal to 17 minus x squared over x. And I sketch the graph for everyone and also identify the upper and the lower limit in this case. And what we have in this case is we have the upper limits as e. And I want to remind everyone that e is a special number and e is actually equal to 2.718281828, and it keep repeating itself. So this is the number e. Okay, it is a very important number in terms of electrical and electronic engineering. I thought I go over this example because it's also involving the integral of involving a natural logarithm. Okay, and natural logarithm has something to do with the number e, right? Okay, so I identify the 1 and the 2.71818 roughly around here for everyone. Okay, so 2.71818, so it's roughly around there. Okay, so I'm going to identify the area for everyone. So right there. So we should calculate the area here. Okay, so so the area will be equal to 1 to e, and I should have 17 over x. So for this type of integrand, I am going to break this fraction into two individual fractions so I can simplify my term before I can integrate. So I will have 17 over x subtract x squared over x. Okay, we did a similar question with this type of integrand. However, we did that with indefinite integral, and now we actually put in the upper and the lower limit. So you see that I can simplify my fraction to 17 over x, right? And then I can subtract this with x as x dx. Then what you are going to do is you are going to integrate this, and you also subtract the integral of that. So I am going to write it as a equal to 17 divided by x. The integral of that will be 17 times natural logarithm of the absolute values of x. And the integral of x would be negative half x squared. So you take 1 plus 1, which is 2, you divide it by 2. So now I'm going to insert in the symbol for a fundamental theorem of calculus. So I'm going to evaluate from 1 to e, which will be the capital F of e, subtract the capital F of 1. Okay, I strongly recommend that everyone just leave the e because e has something to do with the natural logarithm here. Okay, so now we are going to write a equal to, so first of all, this whole thing will be replaced by the e. So 17 ln of e. E is the 2.71 is already a positive value, so I know that is I don't have to put it in the absolute value anymore. So then I will have minus e squared over 2. Alright, so this will be my f of e. And then I will subtract this with 17 ln of 1 and subtract 1 over 2 1 square. Okay, so where the x is, replace it by 1. So this will be my f of 1. and we just have to perform the order operation in this case. So 17 times ln of e. What is ln of e? Ln of e is actually equal to 1. Okay, so I'm going to, again, I will review to everyone the formulas for logarithm. Okay, so we have ln of e. Okay, so what is natural logarithm? Is the log of the base e of e, and what is exponent of e here should be the 1. So you can see that this will give me the answer as 1. Okay, so I will have a equal to 17 times 1 minus e squared over 2. Okay, so for this part, ln of 1 is equal to 0. Okay, you can use your calculator to work with, or I can review formulas for everyone as well. So this is what the formulas that I want to review to everyone. So I will have 17, and I times 0 here, and I subtract a half. Okay, so let's review ln of 1. If you don't want to use a calculator, I can show everyone how this works. So ln is the log of e, and the 1 I can write e to the exponent 0 in this case, right? So because you raise any number to exponent 0 is equal to 1. So e to the 0 is equal to 1. And I apply the properties of logarithm. I should have this as equal to 0. Okay, so another quick review for logarithm for everyone in this case. So area will be equal to 17 subtract e squared over 2, and then I should add this with a half because you see this is a negative and a negative, so I should have add that with a half. So to simplify this, I can have it as 34 subtract e squared plus 1, everything divided by 2 as the common denominators. Then I should have 35 minus e squared over 2 as my final answer. This should be unit square. So if you want to convert this to a decimal notation, your answer should be 13.80547 as decimal notation. Alright, so I also want to remind everyone that there's a couple questions that I would like everyone to try. Okay. Just to recap what we have done. In this particular example, okay, so we have the upper limit as e. I strongly recommend that we leave the upper limit as e, and then we can apply the fundamental theorem, integrate, and don't worry about that e. It's probably take care of itself at the end. And at the end, you can perform the order operation here, and figure out this answer, 35 minus e squared over 2, or if you want a decimal notation, you can just take that number 2.71A2, square that, then take that away from 35, divided by 2, you should have this decimal notation number. Alright, thank you everyone.